Hi, welcome to the second session on doing a threat model for the SafePads COVID application. This is actually going to be one of a second of many because we're going to schedule a whole bunch of them next week, actually as one of the outcomes of today's session. And just kind of very quickly, we expect you to participate, have a lot of respect about everything we do. All about the summit is about openness. Everything we do is open source, and it's very key that we have maximum respect by everybody. We're all here to collaborate, and if you have any kind of anything, let the organizers know, and we feel something about it. Cool. Share your views. There's the Twitter handle. There's a Slack invites, a Slack link if you're not in the organization, and the main thing for you here is to learn. So today's session is about, we're going to continue what we started yesterday on the COVID and SafePads applications. I think what will be really good, Adam, is if you actually just showed us the functionality of the multiple parts, right, of what exists, both the mobile apps and the website, and almost like the user journey experience.
Yeah, it would be really good. I'm having a few technical difficulties. Well, sorry, I should say the app itself is having some technical difficulties right now. So I'm just trying to find a sort of a design prototype that I can show you instead. Yep. But I thought maybe if we could start with the publishing of the points of concern bit. Yep. And maybe, Diarmid, if you could run through that while I try and get a design mock-up up. Mm-hmm. That would be, if you don't mind doing that, that'd be fantastic. Yep. You're on mute, but it looks like you're saying yes.
And actually, Adam, just one thing I want to just throw to the outcome. So I had a number of areas that I wanted them to identify as areas we can work together, from the tools and the most OWASP projects. But also one of the sessions I want us to add to the main summit is where we can work on it before, is almost a maturity model or a criteria for rating COVID apps. Right, and this is basically where we should be saying, here are the 5 or 10 things that we want to rate from a security point of view on a COVID app, right? And that will be source code available, focus on privacy, from the industry, open development practices, pen testing done, security. So I think it's probably one of those for the first 5. You guys are going to be just like checking every single box, right? But it's also, I think, because I was thinking about a conversation we had yesterday about the usage of this. I think it's very important that we also have a way to measure how secure your implementations are, right? I.e., how secure is the forms, right? Because remember that a lot of this is also gamification, right? So I found that from an exec point of view and a stakeholder point of view, it's really hard when you say, look, the master version is all green and you chose to go half red. Right, so that's way more visible. Like for example, if they don't put proper TLS, if you don't put proper systems, if they don't have proper authentication, if you don't have all these things that you want to happen right, we kind of need to put that on a checklist, which got me thinking that is not really just a checklist about you. It's actually a checklist about any app that has this, right? And that's something that we can do a session to almost try to agree as a community that is this good, right?
And there are other apps and other open source projects that are looking at what we're doing, particularly around the OWASP principles and looking to adopt something similar. The projects have all got quite similar names, so people keep accidentally joining the wrong open source project calls, which is quite amusing. But they've picked up on some of the stuff we're doing and are looking at it. So anything like that we come up with, we can contribute into our repo, which then also ripples out across the community.
Which is great, right? Fundamentally, the power of open source is you're raising the bar, you're raising the tide for everybody, right? Cool, right? Diarmid, sorry, is that how you say your name?
Diarmid, yeah.
Diarmid, cool. Right, let's go for it.
Sure. Okay. So where do we want to start with this? I think what Adam was talking about, we talked about the publishing of the points of concern, and the hashing that we use for that. And as we talked about yesterday, it's a sand dune, not a sandbox. And we have some ideas in development using fully homomorphic encryption, where we think we can make this more secure. But that's not something we've managed to implement yet, and there remains some potential technical obstacles in terms of how we do that. What's the best way? Dinis, I think you've seen my fairly long doc I wrote on this.
Yep.
How do you see as the best way to move this forwards in terms of a conversation on a discussion of the threat model?
So one of the things I was trying to understand, right, when I was kind of going to, and I feel that, maybe you could start there, is that what are the areas, right, that you're applying the encryption, right? So if you can can you start with that pattern of you're trying to slow down something, right? You're trying to slow down, a certain type of attack, right?
Mm-hmm.
So let's kind of start there, right? So what is the pattern that we're trying to prevent from occurring? And do you have a diagram that does this, or should I just quickly start creating one?
I'm not sure of a diagram that particularly talks to that. What we're okay.
So maybe why don't you put the document up, right? Or should I put the document up here?
You can put that up if you want. It maybe makes sense for me to do it, because then I can
Okay.
whiz around to the bits that I need. I just need to find a copy of it. Oops. Sorry, just be there a moment.
Yeah.
Okay. I just need to share this now. I can't share yet. Sorry, we can't both share.
Sorry.
That's fine. Do you want, if you want to keep your thing on screen, then, if you're going to be
No, you can share.
Okay. Right. So there's a bunch of stuff. This article starts from a really top level about the privacy goals of undiagnosed users, diagnosed users, etc. I guess where we've started from on this is there's some. So because we want to offer the undiagnosed users the ability to keep their data on the platform always, then the model has, I believe, to be one in which the points of concern are effectively transmitted to the phone, so the comparison can happen there, rather than the points of concern being, centrally. Because if you have a model where the points of concern are stored centrally and not published, then anyone who wants to query against them kind of necessarily has to share some of their data in order to determine whether there's a match. So we've gone for a model where we want to publish this data. And
that data is going to be public, right? So the points of concern.
So once it's published, yes, it's public. Anyone can download it. Whilst we will delete it after it's like 14 or 28 days, or I can't remember what exactly the policy is, but some fairly short period of time. We obviously can't prevent other people from taking that, archiving it, keeping it indefinitely. So that data is effectively public.
Well, then you might as well keep an archive, right? Because it's like you might as well keep the master source, right? So if you think about it, right, there's actually value in that, right? There's actually value in if you think about it, right? Your data point would always be more trustworthy than others, right? Mm-hmm. And the bottom line is that as soon as you publish it, people will have a copy of it, right? So that data is out, right? In that format.
Well, from a privacy point of view, we don't want the healthcare authority to keep it longer than they need it. We let them configure how long they need it, between 1 and 30 days, I think. But then we automatically delete it from their servers. Yes, and it's also automatically deleted from phones after a certain period of time. So yes, somebody could run a batch to capture it every 12 hours and persist it. That's the only way we really are willing to leave that data floating around.
Yeah, but I think that this is where I think it's important to capture what is a real security feature versus a non-security feature, right? I think if you, I think the problem with some of these words, especially from a security point of view, is that you know, and we have to be careful sometimes, you know, remember that you're also setting the benchmark for everybody else, right? And I think that's important, right? It's like the Facebook thing to saying, hey, can you delete my data, right? Well, yeah, sure, we did, right? And then, you know, of course that, you know, they didn't, right? And I think that's a good example of that you won't be able to control that, right? It's almost like just get that, let's just go past that point to say that, you know, once you publish a bit of information, right, about an infection point, that data you have to assume is public knowledge, right, forever. The only thing you control is the quality control of it. You know what I mean? So for example, like, you know, you can make redactions, you can make changes, you can say, well, that was a mistake, or that's where we are now. But the fact that once you publish this kind of data, that is an asset that is out of your control. So from a kind of to think about from a threat modeling point of view, you know, we have to be careful not to apply a huge amount of security guarantees on that one, because the bottom line is the data is out, right? And then, you know, remember that when we say, well, you have to do this, you have to do that. Well, look, a lot of this stuff, if it can be automated, somebody can automate this, right? And I feel that this is one of those areas. There's a lot of commercial and malicious and even, you know, mischief opportunities to game the system. So you have to remember that, you know, like when we look at the threat actors, I think it's important to take into account that you could have well-funded, well-motivated threat actors being in a system.
That's true, but one thing we don't want to do is for the healthcare authority to capture the data on false pretenses and then keep it there for 20 years, analysing it for research purposes when that isn't the purpose that somebody's given their data for. So from that perspective, we want to try and control it as much as we can. But you're right, as soon as the data's out there, it's public.
But that raises an interesting thing, because if to do that, you actually need to put a legal requirement on it.
Yeah, this is more about privacy law than about security.
Yeah.
So one of the things we're working to do is to make sure that every healthcare authority has a privacy policy that states retention periods, purposes, and that is given to the mobile app user before they disclose their data. That's the closest we can get to legal enforceability.
So, but Adam, I think the question here is, you know, we've said that the health authority will not store the data for more than whatever it is, 28 days, and the data will be deleted at that point. If you publish the data and then delete it, are you know, but publishing it means that anybody else could capture the data and store a copy of it. Have you met that commitment or not? And what Dinis is saying, I think, is given that you've published it and anybody could have grabbed it, you may as well keep it forever. But my concern would be under the privacy law, we're not keeping our commitment if we keep it forever.
So I have to say, like, let me, from a privacy point of view, right? And I had lots of debates on this on GDPR, right? Because one of the questions that you get faced as a business on GDPR is what's the impact, right? And I've for the user, right? And I've been on cases where even I disagree, right, with interpretation of it. But I think it's important to say, like, if I have it, right, and I share the data that I walked down the high road, right, and I went on a tube, right, at the moment, and correct me if I'm wrong, but where's the connection to my privacy on those two data points?
Well, yeah. So all you have is a data point that somebody was in place A and somebody else was in place B. Those two places themselves are not, in theory, connectable to each other as even having been the same person. And so there's this is a little bit of a borderline case. There's an argument to be made that it's not really personal data anymore. But equally, there are people who come on a very different side of this and basically say location data is always personal data because, you know, through whatever other traces there might be, CCTV cameras or whatever, you can trace back to, you know, you can potentially trace that back to re-identify somebody.
Yes, but I actually think that is fundamentally one of the core items here, right? I think when you look at the threats, you understand where does personal data ends, you know, and begins, right? Where's that line? makes a massive difference on a lot of these threads. Because put it this way, right? So you're telling me that I'm giving you my personal data that you're making publicly available on the internet for 2 weeks, and you're distributing to 100,000 or 500,000 individuals, right?
Mm-hmm.
So that data that you say you want to delete after 2 weeks is data that you literally are distributing to every single user of the app.
Yes.
That's right.
Well, I mean, yes and no. In the vast majority of users of the app will not consume that data in that form. They will consume it via the app. So
no, that's a user experience. The bottom line is the data is given to them on their phone, correct?
Yeah, okay, sure. But my point is, you've said it, you're distributing it to 500,000 people. The number of people that will actually do something with that, other than use it, in the app, is going to be far smaller than that.
Okay, if I told you that I took your name, your health history, your credit card details, your passwords, and I distributed to 200,000 mobile phones, but it's behind the scenes, right? All they have access is to a statistic, but all that information is on somebody else's, on 200,000 phones. Would you think your privacy had been invaded?
No, absolutely not. No. So the argument, as I've kind of explained in the document, the privacy here is fundamentally dependent on the redaction, to the point that this is no longer personal identifiable information.
Yes, and
the aggregation.
Sorry.
And the aggregation. So by the time we've been through the redaction process, removed places like place of home, place of work, irrelevant points, and then aggregated 10, 20, 100 people's data together through merging them before it's published. Mm-hmm. That's where the privacy control comes in. And then on top of that, we're doing various things that we'll go through around obfuscation to make it difficult to interpret that data.
Yeah, but at that moment in time, that data changes classification, right? It becomes public domain.
Yes.
Yeah. But Adam, technically, it doesn't cease to be PII. Is that right or not, Adam?
It depends on the region and the view of whoever regulates data privacy. The European Data Protection Board is very skeptical that you can ever anonymize location data, even with aggregation. And the reason for that is because you will always have areas with very small amounts of people in and things like that, or areas that only sort of one person can go to. But by aggregating, by removing waypoints, by redacting, you minimize the degree to which that is personally identifiable information. And at the end of the day, you cannot achieve the goal of the application without having points of concern.
Mm-hmm. Correct. But you see, when I look at that, right, what you then have is, that distinction is super important, because what you then have is you need to have a number of risks that are associated with it or not. I'll give you an example, right? If a country or an individual or a group of individuals determines that aggregation is still PII, there's an argument to be said that, probably you can't distribute it, right? Unless maybe then you're going to have to get explicit permission from all those individuals that that data is going to be published. But I think it's important to understand that, and my understanding of your model is, as soon as it hits a point of interest, it's public.
Yes.
Right? Because it's distributed.
Sorry, what do you mean by that?
It means that you make it available to a wide group of individuals.
No, I understand that. You said as soon as it hits a point of interest, it's public. What do you mean as soon as it hits a point of interest?
Because you distribute the point of interest list, right? So as
soon as a user's data passes through the redaction process and moves on to the points of concern list, then it becomes public. Yes.
Yes. Correct.
Yes, that's correct.
And actually, let me share my screen. Sorry, maybe because I was trying to do something here. Right? Can you guys see that diagram? Oh wait. Here.
Where does the redaction process actually take place?
Currently, the redaction process takes place in a web application that's run by health authority staff. We had some.
So I managed to pull up the various design prototypes and the last version. Is it worth me giving a quick demo of that now?
Yeah. Can I just show one thing?
Yeah, sure.
All right. So it's not giving me that. What I was just trying to do here is basically, yeah. So this was actually a cool tool that I just found that it gives the ability to kind of quickly create things. All right. So what I'm basically thinking here, right? And but this is very important, right? Because from a security point of view, right, the whole thing changes, right, depending on these trust boundaries, right? And this is the security in what you do, right? So if I understand correctly, what you now have is we have basically this, right? So you got three very distinct trust boundaries, right? Where this is the internet, right? Basically public, because this is.
Yep, I agree with those three. Yeah, that's inside the HA.
Right? Yeah, right. That's inside health authority.
I think there's actually a fourth. In fact, Adam, you could correct me if I'm wrong here. I think that there's one that's effectively a thing that's been between you and the individual contact tracer dealing with your case. And then after that, data moves to a point where it is more broadly accessible within the HA. Is that correct?
Yeah, I think you're right.
Yes.
Because there is the, what you guys call the contact agent, right?
Contact tracer tends to be the term we use.
Tracer, sorry, what was the name? Like that?
Contact tracer.
Contact tracer, yeah. So we've got some APIs that are exposed to the web UI that the contact tracer uses, and we've got some APIs that are exposed to the mobile app.
Yeah, and that's because the reality is the contact tracer will see the raw data.
Currently, yes.
Right.
Yes.
Well, yeah, yeah.
But then the contract tracer will then do a first pass at the redaction, right? So there'll be the two steps. There's the first kind of step to choose some of it. Then there's so this is almost like the two-step series is actually redaction, and then there is the anonymization process, right? Does that make sense? So you almost have the two steps, which is you redact and then you anonymize.
Well,
yes.
No, is that true?
Yes. Yeah, because you redact and then you aggregate in order to anonymize.
Yeah.
But is the data not already aggregated before it's put into the health authority's data lake? Oh no, no, because we need the ability to remove an individual's case data, don't we?
Exactly.
So we have to. The health authority has to keep track of whose data was whose, but would never share that with the public.
Yeah, and you see that's different, right? So that's the kind of data that yes, you probably only want to keep, for a small period of time, right? So the workflow here is then that you start. Oops. So you start with. Come on. Yeah. Okay. So you have the raw data on the person's laptop, so mobile phone. You talk to the contact tracer. The contact tracer looks at it and makes the modifications, right? In fact, actually, the redaction actually happens here, correct? In a way, right? Because it's the contact tracer who actually.
Yeah, absolutely, it has to be. Yeah.
Right. So
otherwise you'd have the raw data flowing into the next box, which it doesn't.
Yeah. So the contact tracer redacts the data, then sends it to the step who aggregates it, and then puts in a point of interest.
Agreed.
I think what we're lacking here is the API or the server part that transmits the raw data from the user mobile phone to the contact tracer web application.
So that's, well, maybe we're going to show that app, right? So that when look on the code, right? That's this app here, right? The backend, right? That's this one here, right? That gets the data, isn't it? The Safe Places backend?
It is, yes, that's right, yeah.
So this is the one that has the APIs that you can then use. For example, there's the one to access the code, right? So that's the one that has the access code. Actually, do you guys have a Swagger view for this? Because you got the thingy here, the what's it called, definition in there.
Yeah, I've actually got better than that, I think. I've got the stuff running in Postman at the moment, so
cool.
I can.
All right, so go and share it. But just okay, yeah. We'll just finish this up. So you guys are this kind of from a trust boundary. We have these 4 boundaries, right? We got the mobile phone, the contact tracer, the HA, and then internet.
I think that's right.
And that means that, so that conversation we're having about the data retention and all that jazz, I think there's a different set of data retention here than there. Right? I think here, you're right. You can enforce data retention. You can make data being deleted. In fact, you might want to be even more aggressive, right? You could even argue that once data being processed, it can be deleted as soon as possible.
So the argument against that is the health authorities want to utilize this data for other purposes. So they want to generate heat maps, etc., as well as the public points of concern.
Yeah, but this is where, like in a business, I always get nervous when you talk about data retention, right? And data things, and there's always a team on marketing, on business and stuff that says, oh, we really need to do a lot of other analysis, yeah. which usually means, right, in practice, means creating, another one here called the, health authority data lake, right? And you guess what they're going to do with it, right? They're going to freaking send, right, all this stuff, right? This can be, some kind of database, right? Or, Hadoop or whatever, some cloud, right? And they're going to do is basically, where are we? They're going to do that. Dunk. Now, do you really want to allow that?
I don't think most health authorities work in the cloud yet.
Yeah. Okay. What was it called? All right. So what's the? Give me one of them. Or no? What's Redshift? Right. There you go. Right.
Right. And well, I think that depends on the transformation that happens along that arrow. If it's just a carbon copy of all the data, then that's very problematic. If it's something that is, again, privacy preserving or reducing the amount of detail in the data, so that you end up, for example, just a heat map or whatever, then that's so
my recommendation,
that's more valid.
Right? And I always try to do this, right, is that basically that should be considered to be in there, right? Does that make sense? So from a practical point of view, right? Although you have, that world, from a security point of view, even from what you need to protect, I would argue that you want to treat that data already as public. So I always go to my data lake team and say, imagine I put all, if you say, is any confidential data here? And usually the first answer is, no, it's all right, should be okay. Then I ask, I'm going to put all of that on the internet. Are you okay with that? Yeah. That's when they usually start to backtrack, right?
So I agree with you on that, but just one reminder that within that healthcare authority stack that we provide a reference architecture. So we've done some things around that, like we make sure that the unredacted, unaggregated data is encrypted in the database, but that's a dune, not a box, because we aren't enforcing that boundary with things like network controls, infrastructure controls, because we don't run that infrastructure. We can only put dunes there.
Oh, yeah, but look, remember that. Look, whatever you guys produce can be changed, right? Like that's the bottom line here, right? Especially it's open source, it's designed to be flexible, right? Whatever design pattern you come out of this, right, is always possible for somebody to very easily make it crazy and insecure, right? And then look, the bottom line is like, somebody could take a feed here, right? Like, in fact, sometimes that even happens by mistake, right? Or by accident or by logging, right? I've seen credit card data being exposed on global, systems because somebody, there was a log that got left that happens to log every post request to a file in that computer, right? Or that server, right? Or that appliance that happens to distribute it across all sorts of airports around the world, right? So, you know, that kind of stuff, right? We never control, but what you control is the core patterns of the system. So for example, when you say, oh, they can make a copy, but we hope, or we recommend they do X, Y, Z, I think you have to be very explicit. In fact, you have to say that if you want to keep some of the data for further analysis, you have to make sure that that data is already in a protected way. Or else what you're doing is creating assets, which now you have to protect.
Mm-hmm.
Does that make sense? So from a security point of view, there's a massive difference between that and that.
Yeah,
right?
I'm just interested, Dinis, you keeping the, as you move it in, you keeping the red box around it?
Because it's still a trusted boundary.
So it's represent.
All right,
Sorry.
that, there. So the difference between that,
Mm-hmm.
inside the, in fact, that's the problem, right? I almost bet with you that by now it won't be inside the HA. Because the HA will have outsourced, will have a partner, will have another team, will have something else, and you're going to lose control of that data.
I'm not sure. I mean, I think it's something that HAs are already pretty conscious of. They have quite a lot of confidential patient data that they have to worry about how to store. So
it all has to go through a number of, I think there's only 5 national data centers, and then they distribute anonymized data back to all of the health authorities and the I used to be PCTs, they're called something else now, Foundation. No, I can't remember what the name is, but yeah. So they don't receive anything with identifiable information on directly.
Yeah. And remember that I think on these cases, right, if you have a mature HA, right, that has a really good data lake, that has a really good data analytics, right, and they get asked to go and get the data, they will do it, right? It's like, you know, they will do it. They'll know how to do it. They can get the data feeds, right? In fact, you know, I think you want to argue against them doing some of this stuff. But the bottom line is that, like you said, there's a lot of value in metadata that comes from here that is not in here, right? I think the problem is, how do you make it so that you don't create another gigantic data source or gigantic source of data being leaked? Because that's the problem here. If you think about it, what we're looking for is like, see, with this design, right? And if I'm after the data and I'm a threat actor, guess what I'm going to attack, right? I'm going to focus here, right?
Mm-hmm.
Because that's the soft spot, right? If that has a copy of all the data here, you know, why do I go to the main stuff? I start to look at the underbelly here, right? And look, this might be the design that you have, which is one of the designs. I think what we have to then acknowledge is the risks with that. So when you say that, where is my data as a private citizen, right? That I care about it. So I'm here, right? So if you say, where's my data? There's a big difference to say your data or the data for the individual lives in a short period of time within here, lives within a short period of time within here, we get anonymized, and then gets to a point where we believe it's anonymized, and if there's a bug, we'll fix it, right? Then just a bug, right? It's just a vulnerability that gets addressed if you happen to put a data there that can be, you know, deconstructed, right? But there's a big difference to say, and by the way, you get that, but there's also a massive copy over here.
But just to be clear, there is no support for a data lake in our implementation.
I know, but
that's not part of our stack, and we're doing things to make it difficult to do that. This is equivalent to somebody taking our software and completely changing it.
Well, but I think I might, let's take a look at that making it difficult, right? Because, and this is the same thing with, you need to look at your threat agents, and you need to look at who you're making it difficult for, right? So this is where you have to take into account, right? Like, it's the same thing that when you look at attackers, we could say, well, that thing can be done by this attacker. And we might go, well, yes, but the type of attacker that you have won't be able to do it, right? And that attacker that can do that, it has already a lot more options, right, in the disposable. So it's the same thing, right? So one of the areas I wanted to talk about is, when you make it difficult, are you making it difficult for users that, or IT operations, or who would not be able to even do it if they wanted to? Right? Because you know, for example, like Simon here, right, for my team, he's, you know, he's our data analyst special, right? He's, you know, he works with, you know, data every day and, you know, Power BI and Elasticsearch and all that jazz. I'll be surprised if you can make something that is very difficult for him to access the data, right? It's just a question of where to get the data from.
Yeah. I think ultimately the HA has configured the database. They've set up the root credentials. So
Correct.
all we're doing is putting in place some default software behavior to encrypt it, which can easily be disabled. So yeah, we can't stop them doing that.
Yeah.
Agree with you. That is a threat actor, and it's a vulnerability we need to consider. Totally.
And that's the thing, right? It's important to understand who are you putting the countermeasure against.
Mm-hmm.
Right?
I just want to be clear that that box doesn't exist in our reference implementation.
Yeah. Cool. All right. So actually, I guess, is this a correct representation of the key? Although you're right, this doesn't exist at the moment, but it's possible, right? Is what a lot of people will do, right?
Yeah, I mean, I think we know health authorities want to do this stuff. I mean, what I think we mostly talk about there is that is not a long-term data lake, and that we are telling them they should be not keeping that data beyond you know, the 2 or 4 week period where it's directly relevant to, you know, real-time actions on COVID.
Yeah, I'm very skeptical on that. And especially, sorry?
You're skeptical of what, their willingness to comply with it?
I think it's one of those where even if they're willing, right? And again, I think, you know, there might be, it creates tons of technical challenges, right? A lot of data lakes are not designed for data removal.
Yeah, I mean, I work with the PCT that works underneath the health authority, and I know a few people that work for the health authorities there. They're continuously, that they have more Excel spreadsheets than any organisation I've ever worked in. As soon as they get hold of data and they want to analyse it, they will use sophisticated tools, but a lot of the time they're just dragging it down into Excel, putting it into Power BI or another tool and doing it that way. So once you get into that realm, it's impossible to control then. Obviously it's that risk. As long as it's aggregated and anonymized, you're mitigating that risk, I guess. But yeah, they're unfortunately, their technology generally isn't advanced as most other private organisations.
And just to be clear, it isn't aggregated and anonymized. If they decrypt the database and alter the software, they're able to extract it. It doesn't have names against it or anything, but in its unaggregated form. It is redacted, but it isn't aggregated.
Adam, I just wanted to check actually something you'd said earlier. That redaction box is in the right place, is it? So after that initial conversation with the contact tracer, the unredacted data never gets stored anywhere in the health authority systems.
No, I don't think it does, but I think we need to test and check that. It shouldn't be.
Yeah,
the design is that it doesn't.
Yeah, I think we need to look at the code, see who actually does it, because I think the code is actually running here, right?
Yeah, can I give a quick demo just to make this clearer to everyone first, yeah? Can I share my screen?
Yeah. Oh yeah, stop sharing. Cool.
So, first of all, just a quick demonstration of the app. So, in the app, you're able to, this is not working. Okay, there's a button here that says share my location history. So when you're talking to a contact tracer, you would hit share my location history here, and you would select a healthcare authority that you want to share it with. The contact tracer then has a tool a bit like this. This is the old version.
Give me a second. I think I. All right, got it. So it just disappeared from my thing. Cool. All right, so go for it.
Cool. Okay, so this is the old version. We've now got a really much better React version, which I'll show you some design mockups for in a minute, but it's I can't log into it right now. But the concept is basically they load some data in. So here's a bunch of faux location data from the UK, and they're able to, let's say, select a point and delete it, or select a whole area, delete everything in that area, filter on various things like whether this is travel, filter on time ranges for when they're actually infectious. And they may take it down to a much, much smaller set of points that they're worried about. At that point, they can save it down to a database and go into an aggregation screen. And let me just show you the...
Which is this? This is the front-end app, right?
Yeah, this is the old version. But basically, just to show you that there's a map, there's points on there, the contact tracer can delete things. So this is really the redaction process.
And the load...
Where's the data, Adam, whilst they're working on this? Is it stored in the browser or is it stored in a backend somewhere while they're redacting it?
So in the new app, it is injected into the database. It must be unredacted, actually, because it's received by the web service before it can be loaded in here. And then I think once, and I guess the question is more, once the redaction is done, is that data then dropped, which I think it is.
It's not just marked as redacted, it's dropped. But that's the question we need to ask.
Yeah, we need to go and look at that because I think it's different tables and things. So I think it will be dropped from the original tables. The new UI has things like a code that is exchanged verbally with the patient to confirm that they are actually the infected person on the phone. It has things like requirements for the user, the contact tracer, to explicitly get additional consent. And this is probably the third stage of consent in the end-to-end flow. And it looks a bit more modern and reactive. There is also, let me see if I can find some publishing screens in here. Yeah, no, I can't. But the publishing screens, look a bit like this. So, there we go. The publishing screens look quite similar. But they are designed to hold multiple patient data. So one thing that's different here is the waypoints have all been removed. So you aren't able to then draw lines between dots on screens. You would then load in 10, 20, 30 people's data into the same widget, or the record, I should say. You can set some bounds. So you mentioned this yesterday, Denise, maybe you want to set bounds on areas that you publish or don't publish. So we have got the functionality to implement sort of a latitude, longitude based square that you're interested in publishing data on. And there's various pieces of metadata you put in there. And then what publishes out of here is an aggregated set of data, which will have been hashed, this we'll probably come to. And that's the data that goes out into the public domain. So that's kind of a quick demo of like a mix of the new version and the old version, confusingly. From I've just been playing with Postman this morning in terms of what happens when the phone is uploading data to the backend server. And I'm sure you guys will have some thoughts on this, but essentially there's a call to a login URL, which can get a JWT token. But this token isn't actually required for the mobile phone. The mobile phone is unauthenticated because the mobile phone has no trust relationship with the backend. The mobile phone simply calls, the contact tracer creates a case, first of all, in the UI. So they'll send from the UI some kind of message to create a case. I think it's a create case button in the top left, which gives them some kind of case ID. Then the contact tracer runs an authenticated call to create an access code, and they're given a 6-digit access code they give to the user on the phone. And then the user has to consent. If they fail to consent, the access code is immediately invalidated. And then there's an upload call, which includes both the access code that the users heard over the phone and typed into their mobile device, as well as their location history. And this is pre-hashing because this is between the phone and the backend server. So does that give you guys a bit more idea of how this hangs together, or just more questions?
Finish your mute.
Yeah, when I look at the backend code, yeah, it's good to. So that login in the beginning, what is that used for?
So that's the contact tracer logging into the web app.
Okay.
Because the first stage here is the contact tracer creates a case, creates an access code to give to the person on the phone.
Yeah.
Yeah. So only at that point can the phone initiate the contact.
Yeah, and then what you get back from that guy is so you log in, that gets a token, then you go create case. Yeah. And then you pass the token, okay, bearer token there, right? So you pass the JWT token there, right?
Yeah.
Yeah, well, actually, one of the things I was looking is that token secret is super important, right? Because at the moment but you already put down an environment variable, which was really cool. So
yeah, I spoke to the developers. Have I got echo? I spoke to the developers yesterday about adding either IP address or something else as a header as well, so you can't steal the token and use it on a different device.
So the more we can lock it down again to the source, the better, right?
Yeah.
So that gives you so that you put in the case ID, which is your own internal description, and but you're gonna what do you get back from this? Is that the response? Oh, that's the response. Sorry.
Yeah, this is the response. Yeah. So I'm just sending a post with no payload here.
Okay.
I get allocated a case number and some other ID, which appears to be included twice.
Yeah. Cool. So, and that's great. So that the other thing you guys are doing really nicely is the use of GUIDs for IDs. That is really good from a security point of view. So then you got the external ID, and that's when you use that to call it create access codes, right? Yeah, this would be to have this flow somewhere, because I think that's a good one to capture, right? Yeah, and then you get the access code, right? Cool.
Yes.
And then the user has to consent with the access code, right?
That's right. I'm trying to remember if this consent is from the phone. Just go back to the upload flow that we sent around on the Slack and the Summit thing.
I think there's two consents there that we ask the user to make. One is to share the data with the health authority, and the other is to publish, to acknowledge that once redacted, published data will be published.
Yeah. So that's the one you got there, right? So you upload the access code, right? And then you expect a call to that endpoint, right, with access code.
Yes.
Yeah.
To validate the consent. So yeah, this is the user.
Yep.
Actually consenting in the app.
Yep. Cool. And then then the user sends the sends the raw data, right, to them. That's when the raw data enters the system at that moment in time.
Yes, that's right. In this format.
Yeah. And at that time is basically just purely raw, right? So that's the data that's most damaging, right, or worrying at that moment in time, right?
Yeah, it is, because it's one person's data. It's encrypted in transit, but that's it. And
that's the case where at that moment in time the patient is sending, or the user is sending all its data to the health authority, right? To the server, right? To the health authority, right?
Yes, not all its data. Only I think the last 14 days of data is being sent.
Okay, well, because the rest has been deleted, right?
Yes.
So all the data that he has on the mobile phone.
Yes. Okay. Yes.
Right. Either that, or you're storing more data in the mobile phone.
No, you're right. You're right.
Yeah. And
is there any validation that stops say you got a team in Mumbai, I hire a team and I've got them all on mobile phones and they're all ringing up for 8 hours a day. Is there any validation that says that a user can't? Obviously, you could have repeat cases, but there'll obviously be a time frame between when case 1 and case 2 happens, or they share phones in the house. But is there anything to stop the same person spamming individually?
That's interesting. I don't think there is, unless you can think of anything, Diarmid. I think we are relying on the healthcare authority to notice like daily frequent flyers of coronavirus patients.
Yeah, we're doing stuff on the Bluetooth app because we have to be much more careful there to make sure that only genuinely diagnosed patients get in. But we don't do anything like that on the GPS app.
Yeah, so the thing that's interesting here, right, is that I feel that you want to gamify this a little bit to make it hard to send bad data, right? So I feel that at this moment in time, to send metrics or send signatures for the device itself will be quite important, right? And if you think about it, right, the user's already giving you, right, you know, a lot of their data, to be fair, like there's several ways to do it. You can fingerprint the device, or you can just have a unique ID that was given to the device. But the point is that I think you need to track a little bit the data source to prevent some of those cases, but also to prevent automation of some of these things.
So there's a trade-off here, because there's a trade-off between presenting some malicious person claiming to have coronavirus a new time every day versus creating a way for somebody to link a specific phone back to a specific set of data, right?
Correct. But remember that if you give them the ID, so if you have an ID that gets unique created when the app is installed, then there's still no connection with the individual.
What are you trying to protect against here? I'm trying to understand the threat here. So we've said the flow is that there's already a phone conversation going on between the contact tracer and the patient.
Mm-hmm.
And then the contact tracer generates an access code, which the patient then has to enter on their data, so we can be pretty confident that the data really has come from this patient. So you're concerned about people trying to call up and pretend to be people that they aren't and feeding effectively junk data into the system.
Well, they can submit multiple times the same variation of the same data set, right?
If they have multiple conversations with the contact tracer.
With multiple individuals, right?
Right, and then the contact tracer is going to load the data into the redaction tool, and they're going to review that with the patient and talk through all the places they've been, et cetera, et cetera. Seems to me the risk is much more about, if we imagine having hundreds of people tasked with doing this, that there's much more the denial of service on the contact tracing staff rather than the risk of kind of bad data being put into the system here, because it's just so slowed down by the manual process of the contact tracer reviewing and discussing and redacting that data.
Yeah, but this is where I think it can get interesting once you look at the potential threats and the business models of somebody exploiting this. Because I think something I was reading yesterday was that when you do statistical analysis, you're also going to look at how many times a particular something turns up in a particular event. So how many times an event occurred in a particular location, right? So if I submit the same thing 5 times, actually I'm already skewing, right, the amount of traffic, or 5 or 10 or 20 times that happened on a particular point.
So that would just be disinformation versus like an actual, something that would really.
Yes.
Yeah.
I think an interesting question we haven't talked about yet, and I'm not sure I know the answer, is how does this whole process start? like how does this person get on the phone with the contact tracer in the first place? Because if it's an outbound call from a contact tracer to an individual, then I don't think that the threats you're talking about are very very significant. If there's a call in sent to, just kind of 1-800 number anyone can dial anytime and get a contact tracer on the phone and start feeding their data into the system, then yes, absolutely, this does become
isn't that how it's supposed to happen, right?
It's a national number, isn't there? 119 or something like that, I read.
Well, in the UK?
Yes.
Right. So the implementation of this is down to individual health authorities. I mean, in terms of targets for this solution, we're looking at lots of different health authorities in the US. We're looking at lots of different health authorities in a lot of smaller countries.
Okay.
The UK, we're not looking at this in the UK right now because the UK is doing its own thing with the NHSX app. But I think the overall processes that the health authority is defining around this have quite a big impact on what some of these threats are and how real they are or not.
Yeah, I think I think it would be really good to, and I kind of joked with you yesterday, but I think it would be really good to create a shared responsibility model here. Do you know how that looks from an AWS point of view?
Yes, I think that language would be really useful.
Yeah, because I think it's so. For example, one of the things that I was just noting here was that at the moment, what we're saying is the authentication of the patient, right, is 100% in the health authority's hands, right?
I don't know about authentication, because I think we're authenticating that the person on the phone is the person that has the app.
Yeah, but
I think is it authorization?
No, the authentication of the patient, right, who the patient is, right, will, at the moment, you're delegating that to the health authority.
Yes. Okay. Yeah. In that context.
Right.
Yeah.
And then the health authority is the one, or the government, that will get to determine, so for example, right, like I did a test, in London, and I was asked to upload a copy of my passport to a particular website before they gave me a case number. Not to say that's the best thing to do, but there's a validation there, right? So so we're saying here is the authentication. So you're delegating the knowing who the customer is, which I guess the good news is that removes a lot of the potential for noise, right? Because if they allow multiple people, if they have a broken authentication model, then they allow multiple submissions, right? And then what you're saying from the app point of view is that the app at the moment makes no validation and no claim on the kind of the authenticity of that data, apart from the fact that the person on the phone has the same key that the person, on the other side.
Exactly.
Cool. And that's fine, right? But you see that what we're doing is we're defining the kind of the areas and the claims that we can do from a security point of view, right? And the trustworthy that we have on that data, right?
What I'm wondering is, how can I become a health authority?
Sorry, I think we missed you there.
What I'm wondering is how I can become a health authority. What process on the app? What process?
So just to recap, we talked about 4 areas yesterday we want to focus on, and that was one of them, the central infrastructure asset that governs the approved health authorities. We talked about the publishing of points of concern, which I don't think we've finished on yet. We talked about the upload of data to the HA, which we've just dug into a little bit, and we talked about the mobile app that holds the raw data.
Yeah.
Should we finish up on the publishing and the upload,
yes,
and then move on to
the mobile app? I think we could just look at it. Cool. So when I look at this part here, right? So if you go back to here, can you guys see my screen?
Yep.
Yeah, and one of the things to then talk about is the stride of this one, but I think it's better if we just keep the path we're going now, because I can add that later. So we're saying that at the moment, the raw data is fully sent to there, right? In fact, it's fully sent, to be fair, is actually this, right? If we are correct. Because the data
Yeah, I think that
exists
that's
in
correct.
the health authority already. Yeah. So the data is sent to your service, right? Who then gets seen by the contact tracer, who then submits it for the aggregation.
So the trust boundary of the contact tracer there, that is literally the person, right?
Yeah. So this is now.
Then yes.
Yeah. Because the question I think, Diarmid was asking is, so another path could be if the data was given direction to the contact tracer, right? For some, let's say if they upload a JSON file, whatever, it would be technically a bit harder, right? But there could be a situation where literally only the contact tracer has the app, or maybe in another model where there's a desktop computer or something, right? But in this case, the data will exist in your database server here, right? Inside the health authority for a period of time. Right?
Yes.
And what we're saying is that the data starts. So if I put this as the asset, so this is the GPS coordinates, right? So this is literally the coordinates here. So the coordinates, it go from here, and then, and they will now exist in here, right? And they will exist in there. So those coordinates at the moment are seen by these 3 individuals, correct? So let's just change that to GPS.
If by individual you mean trust boundary, yes.
Trust boundary, yeah. So at this stage, the GPS exists in that database, and the GPS is seen by this individual. So at the moment, there's no encryption, correct?
Correct.
And then what you
Sorry, let me clarify. The data is encrypted at rest in both databases, in the user mobile and inside the HA.
Yeah, okay, sorry, but it hasn't been hashed, right? It hasn't been modified.
It hasn't been hashed, correct.
Yeah, so you store in an encrypted format on a database, but that's just a native support for that, right?
Yeah.
And that would actually be interesting to look at actually the encryption, right? Because do you actually use a key to encrypt the data, or you just use native encryption on disk?
I think we just use in our reference implementation, I think we just use a Postgres module that just does it natively. I don't think we're using a key, but bear in mind that a healthcare authority might implement Oracle, they might implement MySQL, and whether they implement that is in our recommendations, but it is up to them.
So walk me through that bit where you now introduce that, hashing and the slow algorithm kind of bit, which is the one I want to kind of understand a bit more, right? So what happens now? You take the GPS data, and then what happens?
That's still, as long as it stays within the HA trust boundary, that remains in plain text.
So even when you get to the aggregation, in here, it's still plain text.
Yeah, but crucially by this point, it's been redacted. So the most sensitive data is gone.
Yeah, okay. So we could say, all right, so we can basically do that, right? So we can say is like that, right?
Yep.
And actually what you're basically then saying is that we then get that, right? Ideally, right?
Yeah, although I don't think that can be green if the other one's not also green.
Well,
because
really? My understanding was that that's already an aggregation of that.
Oh, sorry, the aggregation, yes. Okay, so maybe the aggregation makes it green. I was going to say I don't think that the hashing itself can be seen as changing the color, because as we talked about, it's a sand dune, not a.
But that's my question. I want to understand why. Okay, so in the yellow, this is still clear text, right?
Mm.
Correct. So when you do the aggregation, you're still in clear text.
Yep.
And then you hash. So you're saying that this data is hashed at the moment.
Yeah.
And then, so you give this in a hash, which is given to this app, right? To compare.
Yeah.
Right? So my
But
question.
I don't think we're saying that the hashing makes it green. We're saying the aggregation makes it green, and that occurs inside the HA.
Yeah.
I think those 3 should be the same color.
Okay. Okay. Well, but the point here is when you're doing the aggregation, you still have access to a lot more data than you're going to expose, right?
we still have a correlated case ID. We can cross correlate different data points as being part of the same trail, I think, at that point, Adam.
Yeah, because by definition, at that moment in time, you still have that goes to there, goes there, goes there, goes there, right? You got the ID and the GPS, so you can still track individual cases when you hear.
Yeah. The way I see it, the yes in the raw data form, once it's in aggregate form, the case ID isn't linked to that data anymore. So it depends whether you view, in terms of the reference implementation, the database structure, I think that aggregate box, that data isn't anymore traced back.
Okay, what about if I go like this?
Yeah, that makes more sense.
Right? Right. So basically, that's the process. That's the one that actually is going to try to de-anonymize the whole thing. Sorry, anonymize the whole thing, and that's the one that actually that's the end result of this process. Right. And one of the key requirements for security now is going to be here. Right. So if you think about it, there has to be a lot of rules and a lot of corner cases that have to be addressed in that aggregate process to prevent de-anonymization at that end there. And this might be multiple steps, right? This might be, a sequence of events. But the point is, as soon as the data comes out of here, we have to assume that it's public, and we have to assume that it's in a safe way to be consumed by anybody. Now, my question is, I understand at the moment you guys are hashing from here to here, right? So you're saying that this data is not in clear text, it's actually hashed.
Mm-hmm.
So my question is, what is the threat that you're protecting against? So, okay, so let's put it this way, right? So let me put it like this. Oops. So what you're saying is that you got this, right? Which is basically the hash data, right? So you got so you got this information here, which we can say is now in a place that when he leaves the aggregate process is now nicely sort of clean, correct? Right? Because we're pretty comfortable that that data cannot be tracked to individuals. And then what you actually do is you do this again, where you basically improve its security profile, right? You kind of, almost, well, I guess the color is wrong, right? Because I was gonna make it even more green, right? Can I change the color of this guy? So you actually change his status of okay, let's go like this. Cool, right? So basically what you're saying is that you take the data that we had here and you hash it, right? Which is that step there. Does that make sense? So you take the data that was orange, right? We still have the data in clear text in the health authority, and then you hash the thing to send it out there. Right?
Yeah, that makes sense.
Okay, so my question is, why do you do this?
Mm-hmm. And I think there's probably two arguments. In fact, well, there's three, but the third one's going to be weak. One is about protection of venues and businesses. So it's not about the privacy of individuals, but the privacy of locations that they may have been.
Okay.
One is a general kind of defense in depth protection against mistakes further upstream in the process. So oversights by contact tracers or individuals about what data is actually sensitive. And the third thing was, and I know this is part of the motivation for hashing in the first place, was the scenario in which there's actually a very small number of cases, so that the aggregation is delivering minimal protection. We had a particular concern with some of the very small places we were looking at with very low levels of COVID prevalence, that if we were said to you can't publish data until there's at least 10 trails, the net result would be they couldn't publish data for 5 or 6 days, at which point it would be totally useless. Effectively, it doesn't tell, because the disease has been passed on by then. But I think what you would say to that is, right, it doesn't actually make it any more protected, because the hashing is fundamentally not a secure protection. But that was another motivator for it. To get more comfortable, to get more comfortable releasing small batches of data where it was necessary to release small batches of data because it's needed for efficacy.
But I think this is where we need to look at, the threat, right? Those scenarios, right? So you need to now extract those scenarios. And my question is, when you look at the threat actors of that, like who will weaponize or who will activate on those things, right? So if you look at, okay, so you want to protect the business, right? Then you want to protect the business from information, being abused or from being exposed. But, for each of those, doesn't that also happen with this? So that hash data, right, can't, that also be used for those exact same 3 scenarios?
It can be, yes, but it's harder.
Well, depends on who it is, right? And in fact, you just said the low level of data, right? That means, and I think this is important, right? It's important, like it goes back to, I think Mark on the call yesterday made a couple of good points on for example, the NHS app, right? And there's a moment where you have to also be careful not to over-engineer something, right? See, my worry with this is that from a security point of view, sometimes having a false sense of security can be very damaging, because you're implying that you're protecting the business. You're implying that you can share the low level of data, right? When in reality, you probably are not really, because the individual that will exploit the low level of data can still get the information.
Not readily.
Well, what's preventing them from getting?
Okay, no, they can get it at a cost. Yeah, they can get it at a cost.
Well, but even then, right, that data is available on the mobile app, right? So let's just walk that scenario, right? And I know it's weird when I'm actually saying that you want to reduce the security, right, from a security point of view, but I found myself that sometimes it's very important to understand where your security boundaries are. And so for example, there's a lot of value from a security point of view to understand that all that data is public, right? And you're not protecting, you can't protect, right? So you almost are very explicit with the level, to the point where, if you want to protect against low level of data, that decision should be made here, right? That's a business decision to be made in the aggregate process. So you know what I was saying, that the aggregate process must have probably multiple levels of logic, right? And multiple analysis. There's actually a point of it, which is actually a business decision, or, a healthcare decision, right? Do you share this data? It's a risk decision. Do you share this data knowing that the data points means that, it might be more exposed from a privacy point of view? So it's actually a slider in some of these things, right? So let's look at the workflow, right? So the workflow here is that you don't have a lot of low-level data. So who are you worried? Are you worried about the individual here seeing that data, or de-anonymizing the raw data?
So individual where?
So when we look at the low level of data, let's look at first low level of data, right?
Yeah.
So what is the asset that you're trying to protect? Is it the anonymization process that you're trying to get rid of? You're trying to protect, sorry?
So the aggregation and redaction processes are the ones that offer the greatest degree of privacy and security. And that should be what we're trying to protect most in this process.
So yeah, it's protection again. The concern is de-anonymization of that data.
Yeah. But then who will want to de-anonymize the data?
Any number of people.
All right. But that's a very powerful question to answer, right?
Curious neighbors. National security services, anyone in between. I'm sure there's a long list.
Okay, so that's quite good, right? From neighbors to, you know, NSA, right, or National Security Agencies, right? Okay, and I would say, you know, there's also, you know, like if you look at this, right, there's a lot of agencies, there's a lot of data-driven companies that can make, you know, who might want to use this commercially, right? Which is another kind of problem of individuals, right? So the neighbor, let's look at the neighbor, right? So the scenario of the neighbor, if the neighbor has the app, won't he see the same data straight away?
No, because if he has the app will only show him the data that matches the places that he has been.
And
does it not include your home address then?
Yeah. So the neighbor is once.
Oh, well, the data's been redacted, so it won't match on home. So neighbor as in literal neighbor, living in the next door home.
Yeah.
Assuming his home address has been redacted, then only if they've been hanging out at the same bar or cafe, shops, whatever.
Okay, but if I give the neighbor, right, the list of all the points, and you know that there's a bar down the road that is infected, right? But you haven't been there, but you know that information. Are you affecting the privacy of the neighbor? So you have neighbor A, neighbor B. You're implying that neighbor A is finding something about neighbor B that neighbor B doesn't want. Correct?
If you can have their library and their workplace and some number of other places, there might be enough to draw an inference.
On the actual part of the individual.
But I don't think that requires the data on the app.
Feel rumors, shall we say?
You can expensively unhash the data and see all the points of concern and then draw inferences about what you know about anyone who's been at those points of concern.
Mm-hmm. And you see, the problem that you just identified there is that, so what you're saying is that if my neighbor goes to that bar and works in that office, and he is the only person that goes there, and you publish that data, then the problem, I would argue, is with the publishing of the data. And in fact, it's the publishing of the data with all those points.
So it'll be public information that there's one case in that town, for example.
Yeah. And, you know.
Mm-hmm. And that is already the case without technology. I mean, it is, if an office gets shut down because of a case of coronavirus, or a bar gets shut down because of a case of coronavirus, that stuff is in the local news, right?
See, and that's why I actually think that when we talk about the aggregation process, I actually think that the granularity or the zoom in of what you provide, or the scale of the value, is very important. Because that gives you a lot of security, right? Because there's a big difference to say there's a case next door in the library, in that office, in that supermarket, in that place, which if there's only one person that goes to there, you could track it. But in that case, you probably want to say that there's a case in that area. So, and my point is that I don't see how that low level, that hashing actually gives you that.
It substantially reduces the number of people that will have access to that information.
So, okay, so look, my view on that one, right?
Mm-hmm.
I don't think that's, you know, it's almost one of those cases where if you have credits to spend on security and hashing, this is not where you should be spending those credits on. Now, if you've done everything and you're now looking at, you know, let's really kind of, you know, fine tune this process, because look, all it takes is somebody to set up a service to de-anonymize all the data, right? Right?
Who would, but that's an expensive service to operate.
It's not that expensive. And actually, I think, and we've talked about yesterday, right? I think the biggest concern here is that you are now putting a potential, you know, performance problems on the app itself, on the user. So if you now start to look at low power devices, right, and you look at going wide, right, you might be basically causing problems there. But look, you know, for me, this is one of the examples where you guys can do it. I would either risk saying that is security theater, right?
Yeah, we had these discussions internally. I mean, I don't know. An analogy I used in this discussion, I don't know what you think about it, is that I'm aware that Yale locks are not fully secure and they can be bumped, but I still have one on my front door and I still believe it delivers me as a level of security.
Yes, but this is not a lock. So here's the thing, right?
It's a mechanism that's fairly easily broken by some straightforward technology.
Okay.
But I mean,
I know.
It is an appropriate analogy. I'm sure the number of locksmiths is proportionate to the number of people that can undo a one-way hash, right?
I do think that the false sense of security could actually create a risk there.
Yeah.
If you try to create a sense of security that's not there, it can create a risk.
And remember that what you're saying that your neighbor knows how to code HTTP, knows how to write APIs, knows how to consume data feeds, right? Knows how to take raw data and visualize it and map it out, right? Because that's what's required, right? The difference
what's already required.
Sorry?
You mean what's already required even with it in plain text?
No, because the normal usage of the app is you just see, like you said, the normal usage is the user sees the paths that they have access to, right?
So I think what you're saying is, even if it's in plain text, you already have to have a fairly sophisticated user in order to,
yes. Correct.
I mean, the other position was that the most of the work needed to move towards the hashing was about moving away from these individual GPS data points towards geohashes and so on, and that's a piece of work that's required for the the next level fully homomorphic encryption stuff that we'll be doing as well. So that was a part of the kind of rationale for doing this. The actual script hash is a relatively small cost on top of that. Although, as you say, it does have a cost on the phone that we're analyzing.
And by the way, the hash is always the same, right?
What do you mean by that?
The hash that you create from a point is always going to be the same, correct?
Yeah, it's well, for a point in time, it's always going to be the same.
Yeah. So again, it's a one-off cost of calculating that table, right? Okay, maybe once in time, but
well, one-off cost for every day that you want to analyze.
Yeah. Look, I think, okay, this is the thing I just want to clarify, right? I think this is a good example of sometimes you have to be careful by putting a security measure that actually doesn't add a lot of security. Look, I used to do this with SSL. You know the pattern where you have a website that is in clear text, and then when you go to the login page, you flick to SSL or TLS. Remember that pattern that a lot of sites have? You go in, you in HTTP, you browse the website, then you go to the login page, and that's when you flick into SSL. The problem with that is that the only attacker that you're trying to prevent is man in the middle. And if you man in the middle, you can prevent the user from ever hitting the SSL page or TLS. So all that stuff is now pointless, because unless the whole site is in HTTPS, then you might as well not have anything in HTTPS, because the security advantages are reasonably lower.
Can I ask a question? Given we don't have homomorphic encryption or any of the sort of R&D style ways of protecting this data in plain text yet, are there any ideas about how we could improve on the security of this data between publishing and the mobile app?
Yeah. So I would use the grid. You know the grid that you guys would talk about, worldwide grid, right? I would use those IDs.
Go on.
Geohashes.
So which is a smaller, right? Namespace, right? Because it's instead of being the actual geolocation, right? Which is geolocation, but it's actually the ID of that, and I would control the size of the bubble depending on the data set that you've got.
Right. So yeah, that's like the geohashing that we do.
Is that it? Sorry. Okay.
Yeah, it's just okay. So it's saying vary the scale of the geohash cells based on the number of cases.
Yes. So for example, the first time there's one user in the UK or in Portugal or whatever country or America that use your app, right? You have one value, which is whatever is the minimal sort of square that you want to have. So let's say it's a city, right? So when there's one person, you just get one value, and that's one ID, right? Then as more, and if that person travels, right, then yeah, you get a dot per whatever that person travels. Then as you get more cases, you start to zoom in, right, on that level of granularity that you push in.
The problem with the large geohashes is they generate a lot of false positives if you want to try to use them for this location matching.
But I think that's one of those problems that you're going to have to balance, right? So that's where you really have that slider, right? Where the wider you go with a range, the more false positives, but more privacy. The closer you go, and especially the number of cases, the less privacy you get, right? The easier it will be to de-anonymize this thing.
Yeah, so we have a minimum number of people's data, the minimum number of people diagnosed patients' data that has to be aggregated before you can publish it out. It's configurable, but you have that minimum in place. So it's never going to be one person.
But you see, to me, sorry.
So I mean, that's one of the discussions we were having in the context of hashing. The problem is that COVID moves very fast. You need to contact trace people within 1 to 2 days in order for the contact tracing to have any value.
Yeah.
So what do you do when you're in a place which is only having 1 case or 2 cases per day? If you have to wait for there to be 10 cases, you don't share the data for 5 days, by which time you've got, now you've got 20 or 30 cases because the contact tracing didn't happen. So that with the low numbers, there's a privacy efficacy trade-off that's a difficult one to call.
Yeah, but I think you need to embrace that, right? And this is where there is lines, right? And there is kind of that sort of balance to be struck, right? And we're already making a lot of bad decisions, right? So we're actually allowing good decisions to be made, right? If you think about it, the way we're locking this stuff down, right? But my key point here is that I don't think that you get a lot of value from that hashing. I actually feel that data, in fact, I would even encourage that data to be analyzed, right? Because actually you want to promote, multiple visualizations. You almost want to promote an apps economy here, right? So you actually want to have, almost a visualization economy here, right? This is basically where you want data science, right? Apps to operate. And in fact, the beauty of this, if you encourage this, is this community will help you to really lock down the aggregate process, because their job is to try to make sense of the information. But the beauty of this is that you always start with clean data. And by the way, this will happen, right? Because there's so much value in aggregating this. All you're doing is you're forcing this crowd to do a bit of some calculations, right? And I think there's a lot of value here to put the bar of disclosure here, which is basically like a server-side processing that is within your control. As soon as it goes out there, you don't control it anymore. And you almost have to assume that you don't control it anymore. And I tell you even more, like I would argue there's a lot of even historical and health value in analyzing this. So there's going to be teams that are going to be analyzing this worldwide, right? Because it makes sense to look at all this data. So this data is crazy valuable for all sorts of individuals. So cool. But yeah, look, I think this is one of those where I think it's important to also, as we then zoom in on the threat agents, right, to understand what exactly are we protecting. And my instinct on this is always try to get rid of assets, right? The less assets you have to protect, the less areas where you think you're doing some security, the better it is, right? Because it's very important to be very explicit where your security boundaries are. Cool. And any other place where you have encryption done in this workflow?
Not like this. I think we've got encryption at rest and in transit in various places, but that's less interesting.
So here's the interesting thing, right? I think if you're going to spend credits on encryption, right? And if you're actually going to spend effort, what I would do is I would encrypt it here.
Meaning what?
It means that
it's encrypted at rest there.
Yeah, the problem with sometimes encrypted at rest is we have to be careful, right? That you know, like you said, sometimes you don't control where it goes. And in most cases, the encrypted arrest that you're protecting is literally, right, against, you know, somebody hacking to the freaking data center, right, and going to the machine and yanking the hard drive, which, to be honest, is not that realistic. But you see, for example, at the moment, right, these data, the raw data, can be read by a ton of players, correct? Like all the coding here, anybody that can access the backend on this can read that data, right? When it's on that raw format.
Yeah, the techies at the healthcare authority can access.
But sorry, how does this work with, if you encrypt that data, who can decrypt it and make use of it?
So what you want is a situation where only this person here can decrypt it. Ideally on the browser. So for example, if you're telling me, right, that the only person that will need to see, right, that information is the trust boundary tracer, the contact tracer in their browser, right, then I'll prefer a design that the only place where the raw data exists in the raw data is in that person's browser.
But it also needs to be matched on the phone, top left of the diagram.
Here?
Yeah.
No, I'm saying the raw data here. So
right, the unaggregated data, yeah.
So
prior to aggregation, okay.
Yeah, so this is the mobile app, and this is also the mobile app, right? So this is the SafePad mobile app, right?
Okay, so then it would be decrypted again when it transitions from yellow to green on the right-hand side?
Well, then, yeah, so that would be the other place where you can argue, right? Because remember that there's somebody else who also needs to look at the aggregation process, right?
So let's say
sensitive data is actually is this data here, right?
So I've thought about this a little bit in terms of the having a public key that is linked to each healthcare authority and is published, and having a key pair that's generated on the phone at install, and trying to use that authorization code that's exchanged verbally as some kind of shared secret. I think there is something that could work there, but I haven't fully thought it through.
And here's where it's interesting, right? Now, where you can make it really expensive, right, to decrypt and to process is here, right? Because this is a one-off operation, right? That even if it takes a second or two to process, or two, right? It means that, or more, right? It still means that you're forcing that to everybody. In fact, you're forcing that for the brute force, which will almost make it impossible, right? So in fact, put it this way, right? You know that token you had there? You know, the ID that gets shown, you know, the number, the authorization code, right?
Yeah.
If I basically use bcrypt or scrypt hash, basically hash to encrypt the data to basically be able to decrypt it, right? On that set of GPS data, then I think you basically make it impossible to brute force it.
So all those three pink cells, effectively the data could be encrypted through them.
Yeah, so for example, here, you won't have this. In fact, what you would have is, you know, something like, I don't know, like that, right? Like that, right? Or actually, let's pick blue, right? So that would be encrypted there. So you send the data encrypted here, and then you give a key to that person on the phone. Since you already have that workflow, I will use it. Like, look, to have a back channel with a person validating your data is a massive asset, which you're already using, right, to validate this upload, but you could also use it to allow the decryption of the data here.
Yeah.
And in fact, you can do a similar case, right, of encrypting the data down here, which would actually, even if that encryption will be invisible to the contact tracer, would actually allow you to know which contact tracer actually uploaded what data. And if you, for example, come down the line, have problems or worries about a particular contact tracer, you just go another data point of it. And it also means that, for example, so let's say that the aggregate process is done by a third party, right? So you cannot have a very interesting situation where if the aggregate process is actually done by an independent party, because it's very sensitive, right? We now have a situation where this is a third party, right, trusted, aggregated person. In fact, this could even argue that you might want to be involved in here, right? Because you actually might be able to do this quite nicely. You can even have a situation where this process is actually, you actually have this. See?
Sorry, the only thing I think that's different here is that the raw and aggregated data is encrypted with an application key rather than encrypted at rest, and that we've moved an additional party into the process or additional trust boundary in order to aggregate it.
Well, no, it's also the fact, what you mean with this model here, with that model?
Yeah, so by encrypting the raw data, so only the contact tracer can unencrypt it, that means that the data in the database, when it's first loaded through the web service, is useless to anyone who manages to gain access to that database. So get that. But having a third party do the aggregation, I don't understand how that reduces
because now,
risk.
what happens if you have a malicious or a very insecure or don't really understand very well technology, or not very internet savvy, right? Or compromised health authority. See, with this, I'm removing a lot of trust from the health authority.
Mm-hmm.
Because the health authority does not have the data. So if you look at this model, the only 3 elements that have the data is the individual, right? Is the browser of the contact tracer, and is an independent, right, third-party aggregation process that can be focused and know how to handle that. So if you think about it from a contagious disease point of view, right? Like almost like imagine this was the virus, right? Imagine if this is the virus. Do you want the virus being touched by everybody in the freaking system, or do you want it to contain it in places that we can put a lot of security requirements?
But that does include adding to the centralized assets, which at the moment is just a YAML file.
What do you mean?
Is there any way? So in terms of that third-party aggregate process, so if that's not the healthcare authority, who is that?
Well, I think
it's going to be a
in
party,
your model,
right?
In your model, you are making the health authority do that, right? So in fact, look, you can think like this, right? So if you encrypt the data, right, you can actually say that this happens today, right? So you can say that, imagine you encrypt the data. So this is kind of what would happen today, right? If you encrypt the data from here to there, right? Let's say not with the key, right? I would say with something, or even with the key that you have now. Okay, let's say at the moment you're encrypting the data. My point with this is that if you move this to a third-party process, right? Mm-hmm. You move this to a third-party aggregator process, then basically what they do is, they can focus. They can just, you can put a lot more security requirements in that third-party process than you can with most health authorities. See, my only concern here is that it doesn't scale to push security to the health authorities, right? Because your health authorities, by design, will have a huge amount of distributed. In fact, you're probably going to have this distributed across the country, right?
Mm-hmm.
So the health authorities are a massive weak spot on this.
But a centralized database of assets becomes a massive target as well.
Well, but it can be much better protected. But it's not centralized. Well, it's basically all they're doing is processing the data, right?
So it doesn't store the data?
No. All it does is, and this is where the aggregation process occurs, right? So
okay.
instead of doing it here, you do it.
Okay,
but an aggregation service that doesn't have any data that persists.
Yeah, correct.
So there's a complexity here, right? So you don't publish when you at some point. At the moment, we publish every 12 hours or something, or we expect health authorities to publish every 12 hours. So there is a process by which, after the redaction, the data is persisted in individual, but redacted format. And then the publish process gathers all that together and publishes it. So what we need to do is to make this more secure is not so much to introduce a third party, but to find a way to get rid of all that persistence, right? It's the persistence that's the issue, not whether it occurs.
Well, so the one I was trying to avoid is anybody inside the health authority having access to the raw data, or even the processed data, that without being aggregated. Because that's, if you think about it, in red or even yellow, that's when the data is really dangerous. Right? Those are the places where the data is absolutely super, you know, and if you're going to have a leak of the data or a place where you want to grab it, that's where it's the most damaging.
Yeah, that's why I was asking about how do I get to that raw data? That's the thing that, you know, that's where you get attacked. That's where people make mistakes. That's where things get
so think about it. Any vulnerability on the web app here will compromise that data. You got SQL injection, you have authorization blind spots, any kind of, not any, but like vulnerabilities on this app, right, will compromise that. I would argue that if you move that to a separate app, right, you know, maybe it's run by the same health authority, but a separate place that you can contain, and you know that this is the only place where, and look, we got a patent for this, right? It's called PCI compliance and credit cards, right?
So we do have two separate databases, and we have two separate web service endpoints in order to create some separation there. But that just reduces the attack surface to inside the HA.
But I think that will allow, but I think if you encrypt the data with something that's actually, yes. So if you have that service already separated, then one pattern is to have that outside the health authority.
Yeah.
Right. And you know, when we're talking about the idea of having requirements for making changes, and that's the other thing that would worry me, right? The making customization here is going to be something that probably a lot of health authorities will want to do, right? Because you need to integrate, you need to change the UI, you know, there's a lot of stuff that they might want to do. But in this case, you want to limit the code. For example, this is the code that I would not want anybody to change. Look, the credit card analogy is perfect, right? If you look at the credit card workflow, it's exactly the same thing. In fact, and in fact, if you look at some of the best modeling in credit card these days, is you encrypt the data on the client, and only the payment processor can actually decrypt it, which is a variation of this. But I feel that the one that you can already win, maybe in the short term, is actually looking at encrypting the data between the user and the contact tracer. Because what that means, it means that the raw data, right, the data that is at the most explosive, because you haven't taken out, right, what's it called, the damaging parts, never exists apart from the user mobile and the contact tracer desktop, browser.
Yep, I agree with that. I think the only question there is whether that's the right investment to make, or whether we want to be moving the redaction process under the control of the user themselves, which is another way of solving that problem.
Yes, that's right.
I think, to be honest, I agree with you. I think you're going to have to move some of that redaction over here. I'd be amazed, especially in the model that you have, that the contact tracer would always not make some more changes. But I think
that's probably true. Yeah. Fine. So therefore, there's value in that, no matter what. Yeah. Agreed.
Right. Because, and in fact, I think what I would do with that one is I would basically develop the same UI for both. Right. I would actually create a UI, almost create a version of the app that is literally the same UI for the user and the contact tracer. Because look, one of the comments you guys made was on the documents was to say the users sometimes might not be in a state, right, to make good decisions. So I think one of the things that the contact tracer also will have is that common sense, right? Is that understanding that probably you don't want to share this, you don't need to share that. This is okay, right? And I think that a lot of users might not be able to make that analogy, so that those decisions by himself. Cool. But this is, yeah, so I think that, but I feel, but this is a good example, right? If you're going to add encryption and you're going to make it hard to decrypt, I wouldn't do it here, right? Where I think the security gain is minimal. I would do it here where the security gain is maximum. Because if you hash this data, right, it's like you say, you know what I mean by hash the data, right? So you create a symmetric key that is, it's like SSL, right? You create a massive massive symmetric key, and then you encrypt that, right? And then that's what you need to decrypt, right? So you decrypt the key to give you the symmetric key, but you encrypt the key using bcrypt or scrypt or something like that. So you make it at least 1 or 2 seconds cost, and then you make it literally brute force impossible to brute force that key within the universe of realistic time, right?
Yeah.
Cool. Now, and look, I'll capture this, right? And I'll put this some stuff for us to continue. I think it would be worth just looking at the app quickly.
Yeah, so I've actually got to time out 5 minutes before the end, unfortunately, to take a client call. In terms of the app, I think there is probably more than 5 minutes worth of discussion we need to have on it. And also, we haven't really covered that central HA asset, which I think is probably one of the most vulnerable pieces of the infrastructure, because DNS, amongst other things.
All right, which one is that? Is this part here?
No, so we've got so separate from all of this, there's a piece that the path check controls, which is a YAML file which lists approved healthcare authorities that are allowed to operate the infrastructure.
Yep.
And the mobile app talks to that in order to find out where it can send data, where are the different approved healthcare authorities.
Yeah.
It's a relatively simple file. It's got like a URL. It has GPS bounds that we think the healthcare authority has the authority to operate within. And I think that's it. But it's posted as a HTTPS URL. So one of the things I'm wondering about that is surely within any kind of, if you're a country, you can just change the DNS on that and bypass that whole piece. So I think there's a whole threat model around that as well that we need to include.
Yeah, but then so I think again, like, it's important to understand who are you defending against, right? If you're defending against who can change the source code of your app, then there's probably nothing you can do about it, right? If you're defending against people using your app out of the box, then yeah, I think probably not DNS. That's another good example of encrypting resources. Do you know what I mean? So one of the things that would be good for you to think about is that you can give your app keys, or you can give your app, places that you can go and get keys to get safe data, right? But it's an interesting one, right? Where if you want to have you're basically creating a massive asset, which is, you want to publish almost a white list, right, of things. I actually would argue that you probably want to find a partner to do that for you. If you want to play that game, right? I would actually find, a main provider. Look, AWS, right? Find, a big player that who already has a pretty good secure infrastructure, who can basically be comfortable to saying, I'm happy to protect, that GitHub repo, right? I'm happy to protect. Look, another way you can do is you can use GitHub, right?
That's actually what we're doing, using GitHub right now.
Right, but then there's a question of, look, if you use GitHub, right, then you can basically list the security protections that you're doing, from having separate accounts, having A2FAs, having particular quality controls to get that file there, right? And then you have a separate account for that, and then you publish it. But again, I would talk to GitHub and say, dude, can you guys help us to protect this, right?
But there's no way we can secure that with any kind of we can't ensure that file is a genuine file.
Well, you can't. Well, look, it always starts with one secret, right? There has to be something, right, that the mobile app has that it can use to unpin everything else, right? But
how do we stop that from being reverse engineered given it's published, or the source code is published?
Well, but you don't. But think about it, right? So if you publish a private, the same way that you said you have the private keys for deployment, right? If you publish the public key of your private key, then you sign all those documents, right? All those files with your key.
So use a certificate authority to help.
Well, no, it's a certificate authority, right? You can issue
public key.
you have a public key, right? So,
Yeah.
and the only thing I would do is I would make it so that you can rotate it, right, easily. And I would put as part of the rotation, you know, a process. But you have a public key. The only question is, where do you get the public key from, right? So you can get the public key on installation, right? So you can put it on your phone. That has the problem that you won't it's harder to rotate, right? Or you can say, go to these websites to download the public keys or to confirm the public keys has changed, right? And then
doesn't that solution make you just then have to protect that website? That becomes just as vulnerable as the original asset, doesn't it?
Well, yes, but remember that, you know, it's much easier to protect one asset, right? Than
oh, so you redirect that, you protect that with its own non-rotating public key, private key.
Yeah. So
and then the main asset. Yeah. Okay, that makes sense.
But look, like I said, like you're always going to have one secret, right? There's not secret. No, there's going to be one thing that the user has to have, right? That it, you know, it underpins everything else, right? The question is, where do you get it from, right? And so if you, but remember that what you're doing here is that, to be fair, right? It's almost like, you know, cameras already do that. Like, look, when you look at Ssl pinning, right? Ssl pinning is when you put a cert on your phone that confirms which website is, right? And the bottom line is that if you lose your cert, you have to issue a new app update. There's no way around it, because by definition, you pinned that that mobile phone with that web server. So that's the kind of same thing here, right? So if you push the cert that you expect to talk to, I like the idea of putting the key, because it allows you that it's not just a cert, but it's any kind of data, right, that you've got, right? So I think that the advantage of using a key versus a cert is that the certs, like, again, the private key exists in a lot of more places, where, you know, if you have a private key that you own, then only that laptop or that environment with that will be key ideally, or something like that, has the cert that you can use to sign the documents that you can publish. So at that moment in time, you almost don't care too much about where you're publishing it, because you still have the key.
I've got to drop off. This is really useful. I hope we can continue this conversation on the Slack channel as well. So
Adam, can you list me next week and Diarmid, what would be another couple of times that we could continue, right? And what I want to do, and this might be something that if you guys can join is great, but I want to try to get a couple of sessions with the ASVS crowd and with the ZAP crowd and mobile testing guide, because I want to basically get them to say, look, we should be writing tests for this, right? And also the thread modeling crowd is saying, hey, let's take my half-baked drawings and make it better, right? But I think it would be good for us to do a couple of sessions where at least the three of us are on it. And more about, please turn up too, right?
Great. Catch you on Slack. I've got to run. Thanks, Dinis. Thanks, everyone.
So then I think we're good, right? I think we can sort of, any other comments from your side? No, I think it's a good time to wrap up. It's been a useful session. I hope it's adding value, making you guys think a bit. Yeah, absolutely. Yeah, I know it was a bit weird, surreal, you know, when kind of went on that thing about the hashing, but I always find that I think it's very important to understand why we do a security measure, right? And I think sometimes it's easy to spend a lot of time and effort and complexity, right? And my also experience with development is that the less moving parts in the system, the better it is, right? Yeah. Yes, I'm still very. I can on that one. I can see we might get to the open data, encouraging a whole bunch of data scientists to access its stuff. I can see we might get there. I think we just don't know enough about this space to be confident that that's the right model to sort of promote from the start. I'd be, yeah, I just, the risk of that backfiring in terms of kind of negative publicity about, you know, things that people, you talked earlier about privacy and surprise, people being surprised by, you know, something coming out. I think that really worries me a bit until we learn a little bit more about what this all looks like. But look, in this case, it's always better to define the rules of the game right up front, and to not wait for you to be successful to be hit with that problem. Like the bottom line is that, you know, think about it, as you grow,
you have a lot of margin for error, right? Because again, there's little data, there's little stuff, it's beta, etc. Right? That's actually where you really want to make sure that you set the foundation for everything else, because all this stuff gets really hard to do. It's like, this is one of those things where a little nudge in direction makes a massive difference, right? In downstreams, especially with data, because once you start to have data out there and people start using it, you can't change it as easily as possible. Right? I
agree with that. The challenge was we're working on getting the reputation for this technology established, the questions about establishing its efficacy and so on. And yeah, it just I think very, very sensitive to potentially a narrative of, hey, they, whatever data they do, they just throw it out there for any data scientist who wants to analyze. The risk of that backfiring is actually quite high as well.
Look,
so
this is a good example of us leveraging the community that we have here, right? That's a perfect example of, we can publish that pattern, right? And then actually get the community, right? Which is basically the ones that have the security expertise, right? That if the data backfires, who's going to comment it is going to be the security experts, right? Get them to look at it and going, actually, I think that model is sound, right? Or actually, let's add the hashes, or let's add another hash, right? But I think this is the sooner we can go out there with that question, right? The more you get that validation to know where that line is, right?
Sure.
And remember that one of the problems that some of the apps had is that actually the security community turned around and said, this is way over-engineered, and they're still not protecting the basic stuff. And actually, they could do this much more simply over there, and they're missing the point of a lot of other things. So
absolutely, yeah.
They did a lot of encryption, and sometimes the security community can go, well, actually, you're giving yourself a lot of work, and then you might get some of those things wrong because you open yourself up for problems, especially for an asset that already is always going to exist.
Yep, agreed. Okay, it's absolutely fantastic that you're involved in giving this input. It's something that we've been trying to figure out how to get more people involved from the security community for a while, and so it's absolutely fantastic this is happening now. Cool.
Look, my point of view on this is always like, it's a business decision, right? I just want to make sure that whoever's deciding that feature from a technology development and an app point of view understands the trade-offs, right?
Yep.
Then you can make that decision. It's fine, right? I'm all up for security in depth, right? I'm just worried when that becomes, what the compromise of that against other things, is not there.
Yeah, agreed.
Brilliant, and great for you guys engaged. Now this is really fun, right? And it's a really good thing.
Excellent. Yeah, great talking to you. Looking forward to working with you going forwards.
Yeah, see you on the channel, and let's continue next week.
Okay, brilliant. Thanks. Bye.
Thank you.